We started this chapter, we talked about the subatomic particles. We talked about protons, neutrons, and electrons. And we said that protons and neutrons are found in the nucleus. And we just said electrons are not in the nucleus. But we didn't talk about what they're doing or where they are. And this is the section where we begin to reveal what the electrons are doing. The electrons are housed in orbitals. And an orbital is the volume of space where the electron has the highest probability of being found. Each orbital will hold 2 electrons. And very important, each orbital is at a discrete or set energy level. And we have this ladder here for a reason. The electrons' energy levels are like rungs on the ladder. You can't stand in between the rungs. You have to stand on the rung. Well, the electron is the same way. It can't be in between energy levels. It either is on this energy level or it's on that energy level. It can't be in between the two. And it instantaneously moves between the two. When an electron absorbs energy, it jumps to a higher energy level. So here, this electron is absorbing a little bit of energy and it jumps to the next highest level. When the energy falls, when the electron falls from the higher level to the lower level, it's going to emit a photon. The color of the photon will be determined by the difference in the amount of energy. If the energy is not so great, it'll be a red or maybe a yellow. If the energy difference between the higher level and the lower level is greater, then the light energy released will be green or blue, maybe purple even. So if we look at the spectrum, this is the white light spectrum. This has higher energy, and this is lower in energy. When we excite helium or barium, the top one here is helium, we get these bands. These bands represent the transition as the electron falls from a higher energy level to a lower energy level. And all this black space is because you only have certain levels. The electron can't travel any distance it wants. It has to travel to one of the rungs of a ladder. Now these spectrums, the reason I have barium here is to show you that they're unique for the element. You may have wondered how we know that the helium is in the sun or that a certain star has a certain element in it. The reason we know this is that we study the spectrum of a light that comes from those stars or from our sun, and we will see these bands, and we can then identify which elements are there. So in summary, electrons exist at specific energy levels. When an electron moves to a lower energy level, it emits either energy or light. It's the same thing. Light is energy. To move to a higher level, it absorbs energy or light. And the result of that is these bands that you can see. Now the levels have names. And so the first energy level consists of a 1s. It just has a 1s orbital. And it just has one orbital, and so it only holds 2 electrons. The second energy level has 1s orbital, and it has 3 p orbitals. That gives it 4 orbitals altogether, and so we'll have 8 electrons on the second level. On the third level, we have 1s, and we have 3p, and we have 5 d orbitals. Okay, so that's 9 orbitals altogether, 1 and 3 and 5. That's 9 orbitals. Each one holds 2, so 2 times 9 is 18. On level 4, there's 1 s orbital. There are 3 p orbitals, 5 d orbitals, and 7 f orbitals, for a total of 32 electrons. Now, the Pauline exclusion principle states that each orbital holds 2 electrons with an opposite spin. Spin is going to be represented with arrows. So if we have an orbital represented by a box, we'll have 1 arrow that goes up and 1 arrow that goes down. When we place our electrons into these, we're going to fill the first energy level first, and then move up to the second energy level, and the third and fourth, and so on. In the next video, we'll be talking about determining electron configuration.